Okay, difference of squares, and that's where the okay, it is a binomial of the form x squared minus y squared. And that's a bullet, and then another bullet is it is really a trinomial with a middle term of 0, if you want to think about it that way. Like where's the middle term? Well, it's 0, it's not there, right? So it really is a binomial, but you can think of it as a trinomial with a middle term of 0 if you want to think about it that way. So in general, right, if you have x squared minus y squared, right, we will be able to write that as x plus y and x minus y. That is in general what we're going to do. So if you notice that it's just a binomial and you have a negative in between them, your difference, right? Difference is minus, right? So a difference of squares, if you see that, then we're going to have two brackets and they're going to look identical except for one is going to have a positive sign and one is going to have a negative sign. That is a must. Okay. If we were to FOIL this out, if you just check quickly, this is yx, y times x, right, is xy positive, right? And if you do the double smiley face, x times negative y is negative xy, and that adds up to 0, right? Which is what you want. Like this, the middle term is not there, right? So that's why it has to be a difference. So a difference of squares turns out to be factored like this, okay? And it's fairly easy to recognize. Okay, so examples. Factor fully, and that just means try to get as much out as possible, right? So if you have 81m squared minus 49, okay? And you're like, wait a minute, isn't there x, y? Shouldn't you have two variables? Not necessarily, right? You could have, in any case, you could have multivariable or just one variable, okay? So always keep that in mind. Across the board, it could be multivariable or just single variable, right? In this case, we only have one variable, so it's a little easier. Okay, so how do you know if this is a difference of squares, right? Well, it's a binomial. Check, right? Minus in between. Check, right? What else do we have to check for? Well, think about it. It says difference of squares. So we have to check if the first term is a perfect square and if the second term is a perfect square. Okay, so we check square root of 81m squared. Turns out to be, right, the square root of 81 is 9. The square root of m squared is just m. Because remember, the power of 2 cancels out with the square root, right? And then you check for this one, not including the sign, right? Square root of 49 is going to give you 7. So both terms are perfect squares. Okay, that's also a check. Therefore, It's a DOS. I don't know if you know, I'm sure everybody knows a little bit of Spanish, right? Dos, right? Oh, there's two. It could be a DOS. Not necessarily. Most likely it is, right? It has to fit the criteria, okay? So because of this, we can go back to the original and say that the factored form of that would be 9m. So you've basically determined the terms that are going to be in the bracket, right? 9m plus 7 and 9m minus 7. Do not, it's not a perfect square, right? You can't go 9m plus 7 squared. That would be a perfect square. That's not a perfect square. There's a difference of squares. So there's a plus there, a minus there. And I'll just give you a suggestion to help or to minimize grief. I'll just highlight the signs there, right? And I will suggest to put the negative at the back, and you'll see why in a bit. It's not crucial. It's not going to be right or wrong. It's just going to make it a little easier. So put the first one plus, the second one minus. Let's do a quick check. If we check these two, 7 times 9, right, is 63 positive m, right? And then 9m times 7 on the outside would give you negative 63m, and that cancels out, right? It's 0m. And that's exactly what's happening here. Like that m, the middle term is gone. It's not there. So you'll just be left with 9 times 9 is 81m squared minus 49 if you multiply the outsides, right? And that's where you get that. So if you want to FOIL this out or like distribute, expand, and simplify, you will end up with this. That's how you can always check whether or not you're right. Another one. 27m squared minus, oh, let me put a twist on this. It's easy to do. Does it look like a difference of squares? Well, we don't know. It's only two terms, right? But there's no negative in between, right? So I will show you the steps. Like I remember I told you to rewrite, take out a GCF, take out a negative, all of those steps. It kind of still applies here. I just didn't want to throw the first one example at you with something like that. So I will say this, right? It's a binomial, right? Check if DOS, right? So what I will do is I will take out a GCF. I'll take out this negative. And what goes into both of them? 3, right? Okay, take out the 3. And so you're left with 9m squared. And this would be negative 4n squared, right? Because your 12 divided by negative 3 is negative 4, and the n squared just tags along. Okay, does that look like a difference of squares? It's suspicious, right? It's pretty suspicious. So what I will say is take out GCF, right? And or negative, right? Sometimes there's both, sometimes there's only the negative. And then what I will say is check to see if difference of squares, okay? I see the negative in between the terms, perfect. I make a note that it's multivariable, just like that. I know I'm shortening it, I'm not making a mistake, okay? So I'm just saying it's multivariable. So I have to watch out for that. There's an m and there's an n. Let's do the check here on the side. Square root of 9m squared is going to be 3m, right? Because 9 is a perfect square. M squared, the square root of it is just m. And then you do another check here, 4n squared. That gives you 2n. So both of them can be, you can take the square root of that and have no root left. So therefore, it's a difference of squares. So then you come over here and you still have the, sorry, I should have an equal. Negative 3 never went anywhere, right? Promise to yourself, I will never forget about the negative in front of the bracket, okay? This is 3m. It's just like at home, I'm the only one laughing at my jokes. That's okay. 3m plus 2n. And then 3m minus 2n. Whoa. Whoa. Yeah, it works. Right. So you get these terms when you do your check. All right? And then it has to have a positive and a negative, or else it won't work. Okay? So this is fully factored. If you did not take out the negative and you did not take out the 3, you would have missed the fact that it is a difference of squares. Okay? So be careful there. Example 20. No, I just gave you that one. Sorry. I have a buffet here of examples, and I always pick some of them, not all, or else we'd be here till August. Something like that. Whoa, x to the 4. So I'm making them harder every time just so you know what to expect, right? So again, I'll make this binomial. Is it DOS? Right? Well, we'll see. We'll do some work with it first of all. Let's do the GCF. Remember section 3.3? That's the first thing we did. Take out a common factor if possible. I'll also make note that it's multivariable, right? So can I take out something on for both of them? 3, right? So I'm going to take out a 3, and that's 25x to the 4. Yes, that is an x to the 4 minus 4y to the 4. We're going to perform that check. So here's where you need to put your thinking caps on, right? So if you're at home, wake up, right? 25. I know because people here are awake. I can see that they're awake here. Square root of 25 is 5. What's the square root of x to the 4? X to the 2, yeah. Before, I will tell you why. It comes in the next chapter, but I will tell you this. Just an aside. Square root of x to the 4 can be written as x squared and x squared, isn't it? Right? So if these powers can cancel with that root, what are you left with? X times x, right? Which is x squared. So it's, right? Square root of x to the 4 is x to the 2, right? So x squared. So if you guessed it right, good for you. Then the 4y4, that's going to be 2y squared. Therefore, it's a DOS, right? You've done your check. So 3, 5x squared plus 2y squared times 5x squared minus 2y squared. Okay, so it works every time. It only works if you have powers that are even. Okay, like I could do x to the 6, y to the right, then you can have groups of 2. Also, one more thing I want to tell you, check to see if this one is a difference of squares, because you could have a difference of squared nestled within a difference of squares. You're like, whoa, that blows my mind, right? So check to see if this could possibly be a difference of squares. And you can tell right away that it isn't, because you can't take the square root of 5 and you cannot take the square root of 2. So this is not a DOS, right? Because 5x squared, right, would be square root of 5x, right? Not a perfect square, not perfect square. And I will give an example where that could happen, okay? Difference of squares are easy to identify because you will see two terms and you're like, wait a minute, is this a difference of squares, right? Most likely it will be, most likely, on a test, right? So check to see, that's why I put the negative at the end here, to see if that would break down into two brackets again, okay? Okay, last question for difference of squares. Oh, are you good at home? I hope so. Last question. Example. 81 m to the 4 minus n to the 4. And I will make a note here. When you have m to the 4, x to the 4, etc., you could have within not very common, so you don't have to worry about it too much. Hey. All right. So let's break this one down here. There's a, first of all, you try to take out a negative or a GCF, right? You can't take out a negative. You cannot take out anything else. Leave it as is. Then you take out a square root of 81 m to the 4. That is 9m squared. And you take the square root of n to the 4, which is just n squared. Okay? And so then we have our difference of squares here, 9m squared plus n squared, 9m squared minus n squared. And then you realize, wait a minute, this one you can't do anything. It's not a difference of squares, right? This is a plus here. This one is done. This stops, but you check this one, right? 9 is a perfect square, right? And 1 is also a perfect square. So you can probably break this one down again. So I will go square root of 9m squared is 3m. Square root of n squared is just n. It's a multivariable. So this will make up that bracket there. And then we go 3m plus n, and then 3m minus n. You can't go any further because there are no squares anymore. Okay, so this one, this chunk, these two brackets came out of that one. And this one is just, it stays, right? You can't do anything with it. Homework questions that go with this. And now I'm basically going to take you back to 194, and you may have done some of these already. And I will tell you to do at least half of these. Just peek at the questions. 15a. 15a. 18. 18 is one of those area questions. And find the shaded so you get another shot at it, because we did an example. 20. 21. So these ones, this one would be optional. Right? The 21, I would say it's optional. 15a, right? I will just put a little star on it. That one is a bit more difficult. And I will ask you to take out your factoring booklet now. Everybody in here has it, right? You don't have it? Yeah. We'll give you one so you can follow. I will just hand out this green form as well.